Alrighty, welcome everybody to this little brief meeting today. Um, the focus of this meeting is to help you as student engineers kind of get a feel for some of the opportunities available to you. And I'm focusing on the technology and the aerospace industry today, specifically rocket motors. We'll discuss a little bit about where they started, kind of some of the current challenges, disadvantages, advantages that they're facing, and a little bit as to kind of where the technology is headed. So rockets have the technology, quote unquote, technology of rockets has been around for a long time. Greeks used a very, very crude form of rocket technology and used steam to propel a wooden bird. Later, China discovered gunpowder. They used gunpowder they strapped, fireworks essentially onto arrows, and they used those explosions to propel those arrows to help fight off the Mongols. These were very, very simple and crude, obviously, but they were effective. Later, a German man named Johann Schmidlapp made a multi-stage rocket, which is essentially a rocket is stacked on top of another rocket with potentially another rocket stacked on top of that. The first rocket fires carrying the other two. When it runs out of fuel, it falls off. The next one fires until it runs out of fuel, then it falls off, and then the last one will fire. It's very, very fundamental to modern rocketry, which they say began about 1898 in Russia. During World War II, some German scientists were successful in creating a multi-stage liquid propellant rocket to use as missiles. And both the U.S. and the U.S. and the Soviet Union, or Russia, recognized the military potential behind this and began developing the technology further. Upon recognizing this, obviously, the United States and the Soviet Union began the space race, where they wanted to be the first nation to send men to the moon, to space, launch satellites, etc., and accelerated the industry for many, many years. However, after some time, kind of the late 1900s, 1990s, early 2000s, there's a lot of disinterest in rocketry. People didn't see the need, and the government funding was cut. However, in the last 5-10 years, private companies have decided to commercialize space. Companies like SpaceX, Blue Origin, and Virgin Galactic are looking to make space accessible to everyone, not just government industries. And now these companies, along with NASA, are pushing the boundaries once again. This time, however, they're not just going to the moon. The hope is to send humans eventually to Mars. Now, let's focus on rocket motors. Rocket motors are an incredible piece of engineering. They're defined as something that where thrust is achieved by mass ejection, so that the gas that's from the burned propellant launches out the back of the motor. They are genuinely categorized into two types, a solid propellant and a liquid propellant motor. Solid motors, as what you can see here in this figure, consist of a casing, the propellant, nozzle, and an igniter. Liquid rocket engines consist of obviously the liquid propellant, a nozzle, and an engine, similar in concept to a motor vehicle. Solid propellant you can kind of think of as like gunpowder. It's a solid physical thing rather than a liquid that flows. And many of these rockets, as were mentioned earlier, are multi-stage rockets. Now let's talk about the propellant types, a little bit about what they do. Solid propellant begins as these separate chemicals that they are then mixed together in a massive mixing bowl. I worked for a company this last summer that had these huge, several thousand gallons mixing bowls where they'd mix all these chemicals together. Then separately, they'd build the motor casing, they'd move it and stick it in a pit. Then they'd they stick a mold in there with that, and they'd pour the mixed propellant into that pit with the casing where it's then cured. And then once it's cured, they pull the mold out, and then they attach a nozzle and an igniter to that. Liquid propellant, on the other hand, is, like I mentioned earlier, similar to like a gasoline engine. The liquid, as you can see in this figure here, there's a fuel tank where it's pumped into a combustion chamber, and in this combustion chamber, there's highly pressure, like a lot of pressure, a lot of heat. It ignites the gas, which then it ignites the fuel, which is then turned into gas and forced out that nozzle. Let's talk a little bit about the advantages of each of these. The solid propellant excels in its simplicity. It is so simple. It's pretty incredible, really. They're used as strap-on boosters, as you can see here in this figure. They're attached to other rockets, and then once the propellant's burned, they fall off. They're able to be fired at a moment's notice, which is very, very helpful. You don't have to worry about refueling them. Liquid, on the other hand, generally has better performance than solid rocket motors. Better thrust, they last longer. In general, they tend to perform better. They can change their thrust levels, so they can accelerate harder, they can accelerate softer, similar to like a car. They can shut down and then restart. Some liquid propellants are able to be stored for years in space without a problem. Solid propellant can be launched on demand. Like I mentioned, it's very quick, it's long service life, it's highly reliable, it's almost exclusively used for missiles for the country's defense. You're able to achieve high thrust still with very, very few design compromises, and it's generally cheaper. Liquid propellant, one of the big advantages of liquid propellant is that it could potentially you could refuel on other planets through their natural resources, and in general, it's got a higher specific impulse. Some of the disadvantages: solid propellant, like it cannot stop, and then restart. Once it starts, it has to burn all the way through. It can be really difficult to reuse these rockets, and it can be very dangerous to build them. They have the propellant inside them while people are working on them, and they can ignite really easily. There's a lot of precautions that must be done. If you were to drop a tool on it, it could ignite it and explode a building. So they have to be handled with extreme care, as it could be fatal. Liquid propellant motors are very complex, which can lead to a lot of failure. So if you're in space, you're sending astronauts to the moon and something fails, you're in trouble. They cannot generally be stored for a long time. Usually you have to fill them with fuel and launch them. If you don't launch the vehicle, you generally have to take the fuel out. They're difficult to start in zero gravity. You have to be able to force that liquid into the combustion chamber. They tend to be heavier, and there's obviously still a hazard involved. Now, moving forward, obviously the technology for any of this is incredible, but companies and NASA tend to be focused on fully reusable liquid rocket engines. This is driven mostly by private companies: SpaceX, Blue Origin, Virgin Galactic. SpaceX is getting ready to launch a rocket they hope to orbit the Earth for a few days and then have land back on a pad vertically, you can kind of see in this photo, which is incredible. Never would guess, 10 years ago that something like this was possible. Rockets used to be seen as one time you launch it once and you're done, which is part of the reason why the funding was cut. It was just so expensive. But these fully reusable rockets are able to save a lot of money. And SpaceX is the driving force of this. One of the big bonuses of SpaceX is they're working on, as I mentioned previously, a rocket that is capable of using the atmosphere on Mars or, ice on the moon to turn that into fuel, which can then, launch the rocket back to Earth, which is incredible. NASA and its partners are focusing on currently developing a permanent lunar base, which would be amazing, having astronauts constantly on the moon performing scientific experiences. And then eventually the plan is to send humans and astronauts to Mars. SpaceX is a little bit more ambitious than NASA in this case, as they want to eventually develop a colony on the surface of Mars. And you can kind of see a rendering here of that, which will require a lot. You know, without these rocket motors, none of this would be possible. And for you as student engineers looking into what you might do with your career, this is growing tremendously. There's tons of jobs opening up. It is one of the fastest growing industries right now, and it's truly, it would be able to be involved in something incredible. So I hope this helps improve your intrigue, and I hope you start to think about, you know, maybe looking into a career in aerospace engineering, especially rocketry. Here's some of the references that I used. Thanks for coming. I appreciate your time.